Hi everyone, my name is Miss Duffy and I'll be your algebra teacher for Winter Break Academy. This is our first video for Unit 1, Lesson 1.1 on triangle trigonometry. Unit 1 is on trigonometry. And you're probably familiar with trigonometry from geometry. We're going to kind of take it in a slightly different direction this time in algebra, where we're going to define trig functions for any angle and then graph them. But to start off with, let's remind ourselves about triangle trigonometry, because that's kind of where we have to start. So we have the three trig ratios, sine, cosine, and tangent. And they're defined for right triangles. So this symbol, this is called theta. And that's just a symbol for an angle. It's like a variable for an angle. That's my cat, Ollie. All right, and if we have our right triangle, we always can label the hypotenuse, which is the side across from the right angle. So across from the right angle, this long side is the hypotenuse. All right, then if we start at theta and go directly across, we have the side called the opposite side, because it's across from theta. And then the remaining side, or the side touching theta, is called the adjacent side, because it's next to or touching theta. All right, and we use these sides to define sine, cosine, and tangent. So sine is defined as the opposite side length. Oh my goodness. Divided by the hypotenuse length. Cosine of theta is defined as the adjacent side length. Divided by the hypotenuse side length. And tangent is defined as the opposite side length divided by the adjacent side length. Oops. All right, so those are the definitions. Let's do a couple examples. So let's say we're going to start off talking about angle A, sine of angle A. So angle A is here. Across from angle A is 20, so 20 is going to be our opposite side. And next to angle A is the 15, so that's our adjacent side. 25 is across from the 90-degree angle, so that's the hypotenuse. Okay, sine of A, that's defined as the opposite side divided by the hypotenuse. Opposite side is 20. Hypotenuse is 25. So sine of A is 20 over 25. We can leave it as a fraction, that's totally fine. This fraction we could simplify. So we can divide 20 and 25 by 5. 20 divided by 5 is 4. 25 divided by 5 is 5. So our simplified answer is 4/5. All right, we're still with angle A, so cosine of angle A, that's defined as the adjacent side over the hypotenuse. So the adjacent side this time is 15, so this will be 15, and the hypotenuse is still 25. So cosine of A is 15 over 25. And again, we can leave it like that. We can also simplify this fraction. They're both divisible by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. So the simplified answer, cosine of A, is 3/5. All right, so that was angle A. Now we want to do a tangent, but this time angle C. So we need to kind of rethink how our triangle is labeled here. So now instead of labeling for angle A, we want to label for angle C. So the hypotenuse is still 25. That's always the side across from the 90-degree angle. If I go directly across from angle C, I'm at 15. So now 15 is the opposite side, and 20 is the adjacent side. So tangent of C, that's opposite over adjacent. For angle C, opposite is 15, so we get 15, and adjacent is 20, so 15 over 20 is our tangent. And we could simplify that. They're both divisible by 5, so divide 15 by 5, we get 3. 20 divided by 5 is 4. So simplified answer, tangent of angle C is 3/4. Okay, so that's kind of an intro to sine, cosine, and tangent for right triangles. The other thing I want to talk about in this lesson is two special right triangles that we're going to use as we move forward in trigonometry. So the first special triangle is a 30, 60, 90 triangle. And if we know like one of the side lengths of this triangle, we can fill in all of them because they're always in the same relationship with each other. So 30, 60, 90 triangles always have side lengths in this relationship. The short side across from the 30 is 1, the hypotenuse is 2, and the longer side across from the 60 is the square root of 3. All right, so this is the basic triangle. We can use this to get any 30, 60, 90 triangles. So say instead of 1, the short side is a number a. So I multiplied this side by a. To get the other sides, we just multiplied them all by a. So the hypotenuse would be 2 times a, multiplied by a, and the longer side across from the 60 would be square root of 3 times a, or a square root 3. So we can use that to find the side lengths for any 30, 60, 90 triangle. We'll see some examples of that in a minute. There's also a 45, 45, 90 triangle. So the basic relationships there is that the two legs are 1 and 1, and the hypotenuse is square root of 2. That's the basic setup. We can use that to get the side lengths of any 45, 45, 90 triangle. So say the leg is a. So to get from this triangle to this triangle, I multiplied by a. Then I would multiply the hypotenuse by a as well. So we would get a times the square root of 2. Okay, so let's look at some examples. So here we have a 30, 60, 90, and the short leg is 4. So that's the a leg. So we know a is 4. So we can fill in the other sides, right? This side is going to be a times the square root of 3, or in this case, 4 times the square root of 3. And the hypotenuse is 2 times a, or 2 times 4, which is 8. So we were able to fill in the other sides of that triangle. All right, here's a 45, 45, 90 with one leg being 7. So that's our a value is 7. We know the other leg is the same. And then the hypotenuse is whatever our leg is, our a value, so 7, then times the square root of 2. So this was a equal to 7. This was a equal to 4. Okay, let's try another one. So here's a 45, 45, 90. This time we're given the hypotenuse. Okay, so this is a little trickier. We could say we know in this case that 10 equals a times the square root of 2. We want to know what a is so that we can fill in the legs. Well, to get a by itself, let's just divide by the square root of 2. And I get 10 divided by square root of 2 equals a. So the length of our legs will be 10 over square root 2. All right, one more. This time we have a 30, 60, 90, but we're given the hypotenuse. So this is 2a, right? So to find a, we're just going to divide by 2. So we get 9 equal to a. So that means our short side is just a by itself, which is 9. And the longer side is 9 times the square root of 3. All right, so that's an overview of the 3 basic trig ratios and two special right triangles.